cosmology segment to follow. Random number generated today was 43, which coincides with V662 Cassiopeia. There it is in infrared light on the 2 mass. And let's take a look at it on the Chandra. Hopefully it'll show up in X-ray. How about the multi-mirror project? Nope. How about the Swift bat flux? And you can see it there is indeed an X-ray source there. Let's take a look at it in blue light. We got to zoom way in. And this particular object is, I believe it's a high-mass X-ray binary. There we go, a high-mass X-ray binary. Something like a white dwarf being orbited by a more massive star. Here are the X-ray transients from it. It's also known as 3A0114 plus 650. Entry number 43. 3A0114 plus 650. High-mass X-ray binary / neutron star. There you go. The massive radio source believed to be a neutron star. Here is the 16-year chart of its X-ray outbursts, and here is its 30-day chart. And there is its 3-day chart. Really, it's more like 2 days. It's a 2-day chart. And let's talk about mechanism discovered for making superconductors more resistant to magnetic fields. Guess how it's done, folks? Guess how to make superconductors more resistant to magnetic fields? The answer is make them two-dimensional. Yes, if it's an atomic scale thickness superconductor, it will be able to resist stronger magnetic fields before it's destroyed by them. Kind of important, should be of interest to be stoic, interestingly enough. This one just happened to appear in a SciTech Daily article today. So this one may have implications to cosmology. We decided to include it in the segment. Did you know that healthy diet and exercise in midlife may prevent serious health conditions in senior years? I did, and I don't know why that's on my screen because I certainly did not click on it. Next story is, and this is a good one, this was good enough to make it into the smAsho.com/forum. So check this one out. Astronomers inspect black hole X-ray binary Maxi J1348 plus 630. J1348 plus 630. Massive X-ray binary. Once again, a different X-ray binary, folks. This one is believed to be a, quote, black hole, end quote, but let's just call it a massive radio source to be non-offensive to the largest number of viewers possible here. This one located at about 7,170 light years from Earth. 7,170 light years from Earth, folks, is this particular one, so fairly close by on a galactic scale. And what's interesting in this one is that its X-ray outbursts and radio outbursts are showing, guess what? Proportionality, inverse proportionality, etc. But most importantly, its ejecta has broken a record in terms of its proper motion in through the interstellar medium. So perhaps check out this article if you like. It's on phys.org, and it was enough to make it into our cosmology forum on the most. So this one again, the proper motion of the ejecta launched from it have the highest proper motion ever measured of ejecta launched from a massive radio source X-ray binary. Yeah, that's a mouthful, but anyway, we've got a cosmology topic specifically about it. If you head to smAsho.com/forum, you'll find a cosmology forum, and one of those pinned forums is the most. So Maxi J1348-630 has made the list, and I would put something else in the challenges for our viewers. So here's a challenge for you, the viewer. Check this one out. And we posed this question on smAsho.com/forum in a different forum. This one in the Earth and Geophysics forum, and I consider Earth and Geophysics cosmology, well, because of things like the Earth's Van Allen belt. So I ask you, the viewer, where do all the electrons come from? Anyway, check out that topic. And last but not least, here's your cosmology tidbit. So now that may look a little bit on the obnoxious side, and I agree, that's a little bit obnoxious. So let's take a little bit more of a broken down view as the motion of stars is not quite as chaotic as this, perhaps, but let's just take a look at these 4 pickup sticks in this simple little explanation here. And let's just talk about photons. It is a known thing that the poles of stars emit a different photonic profile than the equators of stars. As when we look at a star from the polar view, including the sun, it looks vastly different than it looks from the equatorial view, right? And so, from the perspective of X-rays, as all kinds of different stars move around throughout the sky, they're creating sheets of ionization pathways. And it's got to do with their X-ray profile. Now, of course, their X-ray profile does change, as sometimes they emit more X-rays out of their equators. So let's just take this to the perspective of the sun. The sun's solar polar field reversal cycles are totally involved in this process, as the sun emits more X-rays from its equatorial region at solar maximum than it does at solar minimum. At solar minimum, the sun most likely emits more X-rays from its poles than it does from its equator. So that's all I really wanted to share, folks. That's our cosmology tidbit for the day, and just let that fester as you think about the X-ray profiles of stars, which are all moving in all kinds of, maybe not as chaotic as this, but they're all moving in sort of all kinds of different proper motions with respect to each other. And that's today's